I'd like to take just a moment to go over standardizing on the table as well as on the calculator. So here's the example. The weight of navel oranges is normally distributed with mean mu is 8, standard deviation is 1.5. So I have a normal curve, the mean is 8, the standard deviation is 1.5. It says answer the following questions. What's the proportion of oranges that weigh less than 8.7 ounces? So I need to standardize that. That changes the x to a z. And I work it out just like this. Grab the calculator. 8.7 minus 8 divided by 1.5. That gives me a z of 4.6 repeating. So I want to know the probability z is less than 0.46 repeating. That rounds off to 0.47. So now I'll look on my chart and I'm looking for 0.47, which is right here, 0.47. That's 0.6808. That answer right there is what I'm looking for, 0.6808. So the answer here is 0.6808. Now I also want to show you how to do this on your calculator, although this is the work that I would need to see. Actually, I should also put on here 8.7 and shade this region because it said less than. So this is work that I need to see, but I'll also show you how to work this on your calculator. There is a function, and it's found underneath the distributions menu. So I'm having a hard time dragging that for some reason. There we go. So if I say second distributions, and I go to the second one, this says normal CDF. We're not going to use the first one. We'll use this second one, normal CDF. And the arguments it asks me for are a lower bound and an upper bound. I'll leave the lower bound the way it is. And for my upper bound, I'm going to write 0.46666666666. Leave that as 0 and 1 because it is the standard normal distribution. Hit paste, hit enter again, and it gives me a slightly better value than what I had on my table. So this is the value that I like to see right here, or this value here. Now some of you may have noticed I could also type this in slightly differently. So I'll do it again, second distributions, normal CDF, lower bound. Let's make the lower bound like it is. The upper bound now, I'm going to make it 8.7, talking about ounces. The mean here is 8 ounces, and the standard deviation is 1.5. When I hit paste, chicka chicka whir whir, notice I get the same answer that I had before. Either way is acceptable, or you can simply use the chart if the technology is strange to you. Now in part B, it says what proportion of the oranges weigh more than 11.5 ounces? So 11.5, more than that. You'll recall it was a normal distribution with mean 8, standard deviation of 1.5. So this is 8. This is 1.5. I want to know what's the probability a randomly selected navel orange weighs more than 11.5 ounces. So I will standardize that, 11.5 minus 8 over 1.5. I'll grab the calculator. And this is 11.5 minus 8 divided by 1.5. That gives me a z of 2.3 repeating. Now I could look this up on the table, but I'm going to use the calculator again. And I know my answer needs to be something less than 50%. So using the function I did a minute ago, it's second distributions, normal CDF. My lower bound this time is going to be 2.33333333. My upper bound is some really big number. Really is infinity, but you know, 999 trillion is probably close enough. In fact, 15 is probably close enough. The mean is 0. The standard deviation is 1. I paste it. There's my answer. I could alternatively go second distributions. 11.5, 999 gajillion, 8, 1.5. Paste, enter, same answer. You can see those there on top of each other like that. The next one is really nice when it says, hey, what proportion of the oranges are between 6.2 and 7 ounces? So I'll draw my curve like I've always done because I expect to see a curve. Here's 8, here's 6.2, here's 7, here's the area I'm interested in, here's the standard deviation. So I'm looking for the oranges that are between 6.2 and 7 ounces. Now, regardless of what little trick I know on the calculator, I still have to show this step. So on my calculator, I've got 6.7 minus 8 divided by 1.5. There's the first value. It's the value that goes here. Negative 0.86 repeating. Negative makes sense because it's less than the mean. And then I'll do the other side, 7 minus 8 divided by 1.5. Again, getting a negative number because it's still less than the mean. But now when I stick this in my calculator, second distributions, normal CDF, my lower bound is negative 0.8666. My upper bound is negative 0.666. The mean is 0. The standard deviation is 1. Paste, enter, chicka chicka whir whir. This value right here is the value that I'm looking for. This is my answer right here. Now, if you don't like this, use the chart. There's nothing wrong with using the chart. On this particular question, if you use the chart, you'll have to subtract a couple of numbers because we have two different things, but that's fine. Now, I find this particularly helpful on a question like D. D says find the 80th percentile, and see where that value of X falls. So what I'm looking for is what thing goes here to give me 80% of the data there. And then, of course, I know the mean is 8 and the standard deviation is 1.5. So what I'm going to try to figure out from my chart is where that 80th percentile falls. So I'm looking in here, and it looks like 80th percentile is right there. Let's move this over and make sure. Yeah, right there. So it's 0.84. 0.84. So back here, this 80th percentile is 0.84. Now that 0.84 is a Z, not an X. So I need to take the 0.84 and unstandardize it. .84 times 1.5 plus 8, 9.26 is the answer I'm looking for. 9.26. So a navel orange that's bigger than 9.26 ounces is at the 80th percentile or greater. Now, I'm going to also use the calculator to solve this instead of the chart. So there's another function under normal distribution called inverse norm. That's working these normal problems backwards. So this is number 3. The area is 0.8 because it's the area to the left, 0 and 1. Paste, chicka chicka whir whir, 0.84. Same thing we got, just with a little more of its decimal glory. Now, That's the way I would use the chart. Here's an even more impressive deal. Same thing here, but now change my mean and standard deviation to the problem. Hit paste. Look at that. It's exactly the same answer that I was looking for before. Now, using your calculator, again, doesn't remove having to show any work. You still have to show all the same work. I still had to show all the steps here. Still have to draw a picture. But using your calculator for some of you will be easier than using this chart. And accordingly, you're welcome to do so.